Despite over 60 years of searching, the Milky Way's 100 billion stars have yielded no confirmed signals from extraterrestrial civilizations. Not one. And here's the question that should keep you up at night. With billions of Earth-like planets orbiting billions of stars, with a universe 13.8 billion years old, why has no one called? That question doesn't just haunt astronomers. It haunts the entire human story. Because depending on the answer, we are either the luckiest species that has ever existed, or we are standing at the edge of something far darker than empty space. On a summer afternoon in 1950, 4 physicists walked across the grounds of Los Alamos National Laboratory in New Mexico. One of them was Enrico Fermi, the man who had built the world's first nuclear reactor, who had helped design the atomic bomb, who was, by any measure, one of the most precise scientific minds of the 20th century. The conversation was casual. They were talking about flying saucers, about a cartoon in the New Yorker showing aliens stealing New York's trash cans. And then, over lunch, Fermi went quiet. He did some math on a napkin, the kind of back-of-envelope calculation he was famous for. He looked up and asked a question that no one in that room could answer. "Where is everybody?" He wasn't being funny, he was being exact. The Milky Way is roughly 100,000 light-years across. A civilization even slightly more advanced than ours, one that had mastered interstellar travel, could colonize the entire galaxy in somewhere between 5 million and 50 million years. That sounds enormous. But the galaxy is 13 billion years old. A civilization that emerged just 1% earlier than us would have had 130 million years to spread. They should be everywhere, on every planet, broadcasting signals across every frequency. But there was nothing. That gap between what probability predicts and what we actually observe became known as the Fermi Paradox, and it would drive scientists to obsession, spark billion-dollar programs, and eventually fracture the scientific community for decades. Here's what those 4 physicists couldn't have known in 1950. The search for an answer would eventually force humanity to confront the most unsettling possibility in the history of science. 11 years after that lunch, a young astronomer named Frank Drake sat down at the National Radio Astronomy Observatory in Green Bank, West Virginia. He had been given access to an 85-foot radio telescope, enormous for 1961, and he had an idea. If civilizations exist out there, they communicate. And communication requires signals. Radio waves travel at the speed of light and can cross interstellar distances. So Drake pointed his telescope at 2 nearby stars, Tau Ceti and Epsilon Eridani, and listened. He called it Project Ozma. It ran for 150 hours. He heard nothing definitive. But Drake didn't stop. That same year, he gathered a small group of scientists, including a 26-year-old Carl Sagan, and wrote an equation on a chalkboard, 7 variables, each one a filter, each one narrowing the estimate of how many communicating civilizations might exist in our galaxy right now. The Drake equation. It wasn't meant to give a precise answer. It was meant to organize ignorance, to show exactly what we didn't know and why it mattered. Plug in optimistic numbers and the galaxy teems with thousands of civilizations. Plug in pessimistic numbers and you get a result that stops conversation cold, less than 1, which means we might be alone. Stop. Before we go further, you need to understand something. The Drake equation isn't just a scientific tool, it's a mirror. Every variable you adjust reflects what you believe about life, intelligence, and the tendency of civilizations to survive themselves. And in the 1960s, with nuclear war a genuine daily threat, that last variable, the average lifespan of a technological civilization, felt terrifyingly small. Carl Sagan spent the next 3 decades making sure the public understood what was at stake. He wrote Cosmos. He appeared on television. He argued that the search for extraterrestrial intelligence wasn't a fringe project. It was the most important scientific question humanity had ever asked. If we found even one signal, it would prove that intelligence can survive, that civilizations don't inevitably destroy themselves. The stakes, in his framing, weren't just astronomical, they were existential. By 1984, the effort had grown large enough to require a permanent home. The SETI Institute was founded in Mountain View, California, with $8 million in initial funding, roughly $20 million in today's dollars. It had telescopes, researchers, and a mandate: scan the sky systematically, at every frequency, and listen. For the first time in history, humanity had an institution whose entire purpose was to answer Fermi's question. And then, in a single week, everything changed. Remember that question from the opening? Why, with billions of Earth-like planets, we've heard nothing? We're about to get there. By 1992, NASA had launched the most ambitious SETI program ever funded by a government. It was called the High Resolution Microwave Survey. The budget? $12 million per year. The plan? Scan 800 target stars with the highest sensitivity equipment ever built, while simultaneously sweeping the entire sky for anomalous signals. Scientists called it a watershed moment. After 42 years of amateur and underfunded searching, the full weight of the United States Space Agency was finally pointed at the question. It lasted exactly 1 year. On October 1, 1993, Senator Richard Bryan of Nevada stood on the Senate floor and called the program a waste of taxpayer money. He mocked it. He called it the Great Martian Chase. His amendment to cancel the funding passed. NASA's SETI program was dead. The SETI Institute survived only because private donors, including Gordon Moore of Intel and Paul Allen of Microsoft, stepped in with millions of dollars to keep the telescopes running. But the message from Washington was clear. This question was not worth asking. Except, and this is the part most people don't know, the scientific community was fracturing over a completely different problem. Not funding, not politics, but the answer itself. In 1975, a physicist named Michael Hart had published a paper that quietly detonated inside the SETI community. His argument was blunt. The fact that no extraterrestrial civilization has contacted us, colonized us, or left any detectable trace in 4.5 billion years of Earth's history is not a mystery. It's evidence. It's evidence that we are alone. That complex communicating intelligence is so rare, perhaps so catastrophically rare, that in a galaxy of 100 billion stars, it has happened exactly once. This became known as the Great Filter. The theory goes like this. Somewhere between the formation of a rocky planet and the emergence of a spacefaring civilization, there is a step, or several steps, so improbable that almost nothing makes it through. A filter. And the question that should genuinely terrify you is this: is that filter behind us or ahead of us? If the filter is behind us, if the hard part was the leap from chemistry to life, or from single cells to complex organisms, then we are the survivors. We made it through. The galaxy is empty, not because civilizations die, but because they almost never start. That's a lonely answer, but it's a survivable one. If the filter is ahead of us, if the hard part is what happens to civilizations after they develop technology, then every civilization that has ever reached our stage has been destroyed by war, by climate collapse, by something we haven't imagined yet. And we are next. At 9 minutes into this story, we still don't have an answer. That's not a failure of science. That's the weight of the question. In 2015, a group of scientists and technologists, including Stephen Hawking and Yuri Milner, launched Breakthrough Listen, the largest privately funded SETI program in history. $100 million over 10 years. Access to two of the world's largest radio telescopes, a mandate to scan 1 million nearby stars, the entire galactic plane, and 100 nearby galaxies. They have found no confirmed signals, but the search has produced something else. In 2016, astronomers detected a strong, anomalous signal from the direction of a star called HD 95086, 95 SETI. The signal was never repeated. In 2017, mysterious radio bursts from deep space, called fast radio bursts, were detected repeating in a pattern that some researchers called statistically unusual. Every one of these events was eventually attributed to natural phenomena. Every one. And yet the Kepler Space Telescope, before it was decommissioned in 2018, confirmed the existence of 2062 exoplanets. Extrapolating from that data, astronomers estimate there are 300 million potentially habitable, Earth-sized planets in the Milky Way alone. 300 million. The silence isn't getting louder, but the emptiness is getting harder to explain. Which brings us back to Enrico Fermi's napkin calculation in 1950. Back to that lunch table in Los Alamos. Back to the simplest, most devastating question in science. Where is everybody? There are only a few categories of answer. Either intelligent life is extraordinarily rare, rarer than we want to believe, or it exists but doesn't communicate, by choice, by limitation, or by design. Or it communicates in ways we haven't learned to hear, or it existed, and something ended it. And the silence we detect is not absence, but aftermath. None of these answers are comforting. All of them change what it means to be human. Because if we are alone, then everything that has ever thought, wondered, loved, or feared in this universe has happened here, on this planet. In the last 300,000 years, the entire weight of conscious experience in a 13.8 billion-year-old cosmos rests on one species, on one pale blue dot, orbiting one ordinary star in the outer arm of one unremarkable galaxy. That is either the most sacred fact imaginable or the most urgent warning. Fermi asked his question over lunch as a passing thought, and never published a paper about it. He died 4 years later, in 1954, at 53 years old, before the radio telescopes were built, before the Drake equation was written, before any of the searching began. He just asked the question. And 75 years later, on a planet with 8 billion people and telescopes that can detect a candle flame on the moon, we are still sitting at that lunch table doing the math and coming up with the same answer he did. Nothing. The universe is either full of life we haven't found, or it's telling us something about our future that we're not ready to hear. If this story made you think differently about the night sky, subscribe. We release one of these every week.